Sundials, used since around 3500 before Christ. In ancient Egypt and Greece, these devices measure time using the position of the sun. How it works. A gnomon stick casts a shadow onto a surface marked with hours. As the Earth rotates, the shadow moves, indicating the time of day. However, they only work in daylight and at specific latitudes. Clepsydra, or waterclock. Since the sundial was not useful on cloudy days or at night, around 1400 before Christ, the ancient Egyptians discovered how to create cycles that could be used to tell time. They realized that water flowing from a hole in a water-filled vessel did so at a constant rate. This idea led to the invention of the water clock. In those early water clocks, water flowed out from a hole near the bottom of a stone vessel, and the marks carved on the walls of the vessel indicated the hours. Candleclocks is a thin candle with consistently spaced marking that, when burned, indicates the passage of periods of time. The candle clock has major flaws. It burns unevenly due to wind or wax quality, provides only rough time estimates, and requires constant supervision to track time accurately. Hourglass, also known as a sandglass or sandclock, is a time-measuring device that consists of two glass bulbs connected vertically by a narrow neck, allowing a regulated flow of sand from the upper bulb to the lower one. The duration it measures depends on factors such as the amount and coarseness of the sand, the size of the bulbs, and the width of the neck. The exact origin of the hourglass is uncertain, but concrete evidence of its use dates back to the 14th century in Italy. A fresco painted by Ambrogio Lorenzetti in 1338 in Siena's Palazzo Pubblico features an hourglass, marking one of the earliest known depictions. Astronomical clocks. By the 15th century, astronomical clocks combined timekeeping with celestial data, showing the positions of the sun, moon, and stars. Pendulum clocks. In 1656, Christian Huygens invented the pendulum clock, marking a huge leap in precision timekeeping. A pendulum swings at a constant rate, regulating the clock's accuracy. This allowed for remarkable precision, with errors as small as seconds per day. The pendulum's consistent motion is due to the force of gravity acting on it, causing it to swing back and forth in a regular rhythm. Each complete swing or oscillation takes the same amount of time, known as the period. The clock's mechanism counts these oscillations and converts them into the ticking sound we hear, with each tick representing a precise unit of time. By adjusting the length of the pendulum, the clock can be fine-tuned to keep perfect time.